Please welcome to the stage Sharon Yang from Meta Innovation Partnerships, as well as remote presenter Nikhila Ravi, a Meta Research Engineering Manager. They will be demonstrating Segment Anything Model, or SAM, which is an open source model available for external adoption and also currently integrated into Instagram as the backdrop feature.
Good afternoon, everyone. Thanks for joining us. And thank you, Nikhila, for joining us remotely. As David mentioned, my name is Sharon Yang. I'm based here in DC out of the policy team, working on innovation programs and partnerships. I'm joined by my colleague, Nikhila Ravi, who's in California, who will be walking us through our demo of Segment Anything today. And I'll just be her slide switcher and live demo help. So Vanna White to Nikhila. So Nikhila, can you hear us?
Yes, I can hear you.
How's everybody with the audio in the audience? Thumbs up? Okay. So. I don't know. Can we turn it up a little bit? All right. Okay. Nikhila, take it away.
Okay, great. Next slide, please. Cool. So I'm excited to tell you about Segment Anything. This is a project that we open sourced last year from Meta. So what is segmentation to start with? So segmentation is the task of, can we go back one slide? Yeah, so segmentation is the task of identifying the pixels in an image that correspond to a specific object of interest. Next slide, please. It's used in many real-world applications around us every day. For example, in background removal, for self-driving cars and locating pedestrians and obstacles on the road. Next slide, please. Previously, models were very tailored to specific tasks. So the dominant paradigm was to have models that could excel for specific object categories like pedestrians or cyclists. And they worked really well in these very specific use cases. Next slide, please. But these models are limited to a specific set of object categories and types of images, and they don't work in novel settings. For example, in this image, if we just take an off-the-shelf object detection or segmentation model, it misses many of the vegetables and it only can recognize very few of those objects. Next slide, please. So last year, we released the Segment Anything model, or SAM for short. It's a new interactive AI model that can segment any object in any image with as little as a single click. And it offers a step change in performance compared to previous segmentation models. So I'll take you through how the model works, some of the key benefits, examples of real-world applications, and also what's next on the horizon. So SAM introduces the idea of promptable segmentation. So the model can take various types of user input to specify the object to segment. So very similar to how in a language model or ChatGPT, you type in a text prompt and it gives you a response. We also want to enable this for the task of segmentation, where the user can provide an input to specify the object that they want, and then the model can return a segmentation mask. Next slide, please. So there are a couple of different ways in which you can prompt segment anything. A user can click on an object to segment it. You can also refine the prediction with additional positive and negative clicks. And we can also prompt SAM with a grid of points. And given this grid, it can automatically segment all the objects in an image automatically. No. So next slide, please. So to put this all into context, Sharon's going to show you our web demo, which lets you upload an image of your choice and try SAM on this image. So we also have a gallery of different images that you can pick from, or you can upload your own. So currently, while Sharon is hovering over the image, you can see that based on the cursor position, the model is actually trying to predict the object that the cursor corresponds to. So now it's picking the turtle, it's picking the water, it's picking the snail, or the frog. And this is actually all running in real time in the browser.
Right.
We can also try this everything mode where we're prompting the model with a grid of points. Based on each grid location, the model is predicting what the object is at that point. And as you can see, we can predict all the objects in the image pretty automatically. All right, so that should hopefully put into context what prompting means in the context of segmentation. Next slide, please. So there were two key innovations that enabled the development of this model: the annotation strategy and the model architecture, and I'll briefly explain both. So to achieve strong generalization, which means being able to work for lots of different types of objects in many different types of images, it was necessary to train SAM on a very large and diverse data set. And this kind of data set doesn't exist currently. To train a language model, we can take all the data from the internet, but segmentation masks don't really naturally occur on the internet. And so we needed to come up with a strategy for how to collect this kind of data at scale. And to do this, we came up with the idea of a data engine. So we take the model, we create an interactive setup with human annotators who then annotate masks, and we take that data and we use it to retrain the model. And we do this iteratively. And after a number of iterations, the data and the model both improve. And we call this a data model co-evolution. Next slide, please. The second innovation is architectural. So SAM needs to be efficient enough to power this data engine. And so we have this two-part model design where there's one part that's quite time intensive, and that runs only once per image. And then for each object in the image, as you saw in the web demo, we can in real time predict that object. And so we came up with this two-part model design to enable us to power the data engine and also then improve the model using that data that we collect. Next slide, please. So this two-part model design basically gives what we called amortized real-time inference. Where, as I mentioned, when an image has many masks, we only need to run this heavyweight image encoding step once per image. And then the inference time per object is very, very fast, and it can also run directly in the browser. So with this data engine, at the end, we managed to annotate and collect 1 billion plus segmentation masks across 11 million images that we fully open sourced with a research use license. And this is the largest ever released segmentation data set. It's 400 times bigger than anything that exists currently. And we wanted to put it out into the community for research purposes. And in the past year, we've actually seen, since we open sourced it, we've actually seen a number of other researchers build on top of the data set, add further annotations, and really advance research using this data set. All right, so now I've given you a bit of an overview of how SAM works under the hood. I want to also share about some of the capabilities and why SAM is so useful. So because we trained it on this large and diverse data set, SAM works for objects and images, even in image domains that it has never seen before during training. For example, medical images, paintings, or underwater images. And we call this ability zero-shot generalization. Next slide, please. And because of this generalization capability, we can actually use SAM in so many different applications, and it can also be used as a component as part of a larger system. So we can combine it with different input types and different output types. So next slide, please. So on the output side, the masks from SAM can be used as input to other models. For example, we can go from an image of an object to a 3D shape of the object using a different 3D shape prediction model. On the input side, Sam can take as input bounding boxes from a box detector that could enable something like text to object segmentation. All right, so since we launched it last April, Sam has sparked diverse applications both within Meta and outside in the research and broader tech community. So Backdrop is an AI-powered feature on Instagram. It was announced last year, and under the hood, it uses learnings from Sam to segment the salient object, which the user can then edit the background using a text prompt, which leverages another meta model called EMU for image generation. So we'll now do a quick demo of Backdrop.
Yep. And here we go. Everybody gonna see my phone? Can folks see my phone? No. Yeah. Oh, there we go. So this is like, sorry, the mic's over here. We're gonna do a live demo right now of Backdrop. We're gonna take a selfie. And then we're gonna use, sorry, Nikhila, go ahead and narrate it if you'd like.
No, go ahead.
We're gonna use this feature called Backdrop here. As you can see, it's analyzing, and I'm gonna put myself in the White House. Generate a backdrop. Several different options. You can go next, and when you share this, when it gets shared to your story, will actually also feature a caption that says that this image was generated by AI Backdrop with using Instagram, as you can see on the screen now. So that's a feature that's live and you can use right now.
Right. Awesome. So there's also another feature in Instagram called cutouts that operates in a very similar way. It uses Sam under the hood, helps you cut out the salient object from an image, interactively edit it, and refine the mask if required. And then you can share it as part of your other stories or combine it in other creative ways. Outside of Meta, Sam has been adopted for a wide range of applications, and this is because we've open sourced it with a commercial use license and very simple code that anyone can use available on GitHub. So very soon after the launch, Sam was integrated into many of the largest enterprise annotation companies, and these companies are used by, for example, self-driving car companies. They annotate a lot of data using these platforms. Medical imaging companies annotate using these platforms. So these platforms serve as a foundation for a number of other applications as well. And to quantify some of the impact of this, RoboFlow, which was one of the first, maybe we can go back to the previous slide. RoboFlow was one of the first annotation platforms to integrate SAM. And in the first 7 months since they launched it, about 50,000 people used the SAM-powered tool to label over 13 million images, and it saved them 21 years of labeling time. And so this is a sort of industry-wide impact that we also aim to have through our open source work. So outside of commercial use cases, we really also want to have an impact on benefiting humanity. And in science, and in particular medicine, Sam has had a really outsized impact and revolutionized the way that doctors and scientists analyze images. For example, segmenting tumors in MRI images, cells in microscope images. And previously, these were very manual processes that require a lot of manual labor to draw the boundaries of these objects. And all of this can now be significantly automated using SAM.
And unfortunately, I believe we've reached our time. Nikhila, thank you so much for letting us have these 15 minutes of your time. And thank you, SCSP. Thanks for coming, guys.
All right.